Morning, guys. Well, this is it. We're on the countdown. This is 3. Tomorrow will be 2. And then our colored sheet will be 1. We're almost there. Can you believe it? Anyways, today what we're going to look at is we're going to just do some harder normal approximation type of questions. So today is normal approximation to the binomial distribution continued. Okay, so just, a few different types of examples and we're going to go from there. Okay, a pair of regular 6-sided dice. A pair. Okay, so a pair, as soon as I read that, tells me dice chart. So a pair of regular 6-sided dice is rolled 80 times. Now, again, this is what makes this question not a traditional probability question. Traditional probability, you're just pretending that you're rolling it once, right? And asking yourself, what's the probability? Okay, so it's rolled 80 times. Let me fill this in. Okay, what is the probability that there will be at least 20 rolls where the sum is 9 or higher? So hold on, because when you sit down to do the test, you're not going to know what type of question that you're dealing with, right? So first thing I want to point out is 2 outcomes. A sum of 9 or higher, or not. So now, when there's 2 outcomes, it could be a Bernoulli, it could be a reverse psych Bernoulli, could be a waiting time, or it could be a normal approximation. Now, nothing in this question leads you to believe how long are you going to have to wait. So waiting time's out. Classic Bernoulli would be to run the iterations of the formula. Well, if the game is played 80 times, at least 20 would be all the way from 20 to 80. So 60 rough iterations of the formula. Ridiculous, you're not doing that. Reverse psychology would be 1 minus what the question's not asking. So that would be 1 minus the probability of 0 all the way to 19. So now that's roughly 1920 iterations of the formula. Again, you're not going to do that. So you've ruled out waiting, you've ruled out classic Bernoulli, you've ruled out reverse psychology. Now all we're left with is normal approximation. So normal approximation is a 3-step process. The first step is your NP and your NQ. Your N is 80. Now, your probability of a sum of 9 or higher. We know in a dice chart question that your NS is 36. A sum of 9 or higher is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36. Your NQ is your probability of failure. That would be anything that's not highlighted in yellow, and that would be 26 out of 36. So 80 times 10 divided by 36 is 22. That's bigger than 5. 80 over 1 times 26 divided by 36 is 58. Since both are greater than 5, we can move to step 2. Step 2 says, please calculate your NP, You've already done that. So save yourself a little bit of work. And please calculate your sigma, which is the square root of 80 times 10 over 36 times 26 over 36, all square rooted, 4.006. Now, some of you might be asking, how do I know, Miss Martel, like how many decimal places? The only reason I would probably stick to 2, but the only reason I kept 3 in this case is because it was 006. Okay? Now, step 3 is when we actually get the normal approximation involved in this whole process. So my mean is 22. My standard dev is 4.006. And your big question mark of what you fill in is that hot pink area. Now, I tend to like to draw the line, and it says at least 20. I know I can't use 20 there because 20 is a discrete value, and this formula only works with continuous data. So I know that I've got the choice of the interval between 19.5 and 20.5. I know at least means that I'm going to have all the values bigger than 20. So you have to ask yourself, is 20 being included in the word at least? And yes, it is. So if 20 is being included, then I'm going to start my highlighting from 19.5 so that 20 is included. If I would have started it at 20.5, 20 wouldn't have been included in the subset. So calculator, get it fired up. 19.5 minus 22 divided by 4.006. And I'm now going to have to get my chart out and look for a Z value of negative 6.2. Okay. So before you jump too quickly into your therefore statement, what you have to ask yourself is, which portion of the diagram is this question asking you to highlight? Because we know that this always represents the percentage below. So that 26.76%, that's the percentage below 20. But our particular question is asking for at least. So what we're looking for is this percentage right here, highlighted in the bright yellow. So in order to get your full marks, you're going to take 100 minus 26.76, and you're going to get approximately 73.24%. So therefore, there is approximately a 73.24% chance that the sum will be 9 or higher on at least 20 rules. Okay? So you have to be really, really careful before you slap down your therefore statement and double check what the question is asking. And this was the same thing when we were in the normal unit. We had to be, quite careful and just cautious about what we were up to. Okay? All right. Let's flip when you're ready. Lisa walks the same route to and from school every single day. And she's always finding change lying on the ground. there's a 32% chance that she's going to find a quarter during any given walk. She walked her route 42 times over the past month. What is the probability that she found between $3 and $4 inclusive? Now, again, when you sit down the day of the test, you're not going to know, is this a Bernoulli? Is this a weighting? Is this a reverse psych Bernoulli? Or is this a normal approximation? But this word right here is the big indicator of normal approximation. So you can, oops, sorry, that should be a P. You can let the other techniques go. Okay, and this is going to be a normal because of this word right here. Okay? Step 1. Step 1 says your NP and your NQ test. Well, N is 44. She walks her route 44 times. Probability of success is her finding some money. Probability of failure is her not finding any money. Okay, 44 times 0.32 is 14.08, so we're definitely over 5. 44 times 0.68 is 29.92. So as far as the test is concerned, we've passed because both are greater than 5. Second step is to calculate your X-bar or your mean, and you've already done that, so save yourself some work. Second step is to calculate your sigma by taking your 44 times the probability of success times the probability of failure and square rooting it. Again, you know that I've said be very, very careful with this particular step, okay? Just because the calculator, I don't know why, you just have to be careful here. So I've got my X-bar at 14.08 and I've got my sigma at 3.09. So now I'm on step 3. And because this is a between question, I'm going to write my Z-score formula down twice. Again, I know the mean. And I know my standard deviation, so I can fill that in very, very quickly. But the actual part of these questions that you have to think and be very, very careful is with the X values. And the between is $3 and $4, and it told us in the question inclusive, so it's including $3 and $4. Okay, so, well, we know that we can't use 3 and 4 because they're whole numbers. So we could use 2.5, 3.5, 4.5, or 5.5. And I'm hoping when I'm using the word inclusive that you realize that we got to go to the outer extremities, right? Okay, so hold on, I just want to do something with you, okay? So can you just bear with me? Stop writing when we got all of this. And if I'm going to sub in 2.5 here, because that will include 3, and I'm going to sub 5.5 in here, just watch for a second. 2.5 minus 14.08 divided by 3.09. I told you way, 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 way back that if you get a Z-score that's bigger than 3 or smaller than -3, one of two things have occurred. One, you've made a boo-boo, or two, it's an outlier. Okay, so you're wondering, geez, is that an outlier? Let's try 5.5 in here. 5.5 minus 14.08 divided by 3.09. That's also close to 3. I'm wondering, have I done something wrong? This one was significantly over 3. This one was really close to 3. I'm wondering. Well, let me think about something here. The average is 44 coins times the probability of finding. So that n actually represents the number of coins, But these two values represent the amount of money. So what if I chose 12? And what if I chose 14? 12 being the value of $3 in terms of the number of coins, and 14 being the number of coins for $4. So again, I can't use 12 and 14, but I could use 11.5 or 12.5. I could use 14.5 or 15.5. Now, we made the executive decision, because it's inclusive, that I'm going to use the outer extremities. So I'm going to use 11.5 and I'm going to use 15.5. Now that makes a little bit more sense, because the 1408 isn't a dollar value. It's the number of coins. It's the average number of coins. That's why this question is tricky. Okay, because we would just instantly slap in 2.5 and slap in 5.5. You'd get some sort of wonky answer, okay, which you would think would be an outlier, and you would just keep it going. But you just got to be careful. You got to stop and think, okay, what is this representing? This average is representing the number of coins, the average number of coins, not $14. Okay, so now that we've got that resolved, did I screw something up? I most certainly did. Just dawned on me right now. This should be 16. $4 should be 16 coins. So 15.5 and 16.5. Sorry about that, guys. So again, $3 is 12 coins. $4 is 16. Don't ask me even where I got 14. Okay, 11.5 minus 14.08 divided by 3.09. Z value when I look it up. Sorry about that. 16.5, my boo-boo, minus 1408 divided by 3.09. Z value, I'm going to look it up. .7823. And now I know with the between questions, I'm going to subtract. Approximately 57.9%. Therefore, the probability of Lisa finding between $3 and $4 is approximately 57.9%. Okay, love this question for this little tidbit right here. It's just kind of a cool question, right? Okay, let's keep going. Just gonna give you a second. in 100 rolls of one die, what is the probability that a 6 appears between 10 and 20 times? So again, as soon as you see this word, you don't have to worry. Oh no, is it Bernoulli? Oh no, is it waiting time? Oh no, is it normal approximation? No, as soon as you see the word between, you can just immediately go to normal approximation. And you know with 100% certainty that you're getting a between question on the test. You know that. So step 1 is the test. Now let's think about what's going on here. Your n is 100. That means 100 rolls. Your probability of a success is getting a 6. Your probability of failure is getting anything but a 6. Okay. 100 over 1 times 1 over 6 is 16.6 repeated. Why don't we keep it 2 decimal places? Sorry. And why don't we call it 16.67? Okay. Your probability, 100 times your probability of failure, 5 over 6, is 83.33. Both are greater than 5, we pass the test. Step 2 says, hey, please calculate your average. Already done it. It says, after you've done that, please calculate your sigma. Okay. So that's going to be 100 times 1 over 6 times 5 over 6 square rooted. Again, be real careful, right? Standard dev, 3.73. Now, we're going to do our step 3. And because this is a between question, we're going to jot down the z-score formula twice. Average being 16.67, standard dev 3.73, and the big question, the big issue, and where sillies can be made are, what are you going to sub into those hot pink values? And again, this is where I scoot over to the side and I kind of draw like a number line, right? Between 10 and 20. I know that I can't use 10 and 20 because they're whole numbers. I know that I need something decimally. I need something continuous. So I know that the interval of 9.5 and 10.5 are good representatives for 10. And I know that the interval of 19.5 and 20.5 are good representatives for 20. So the question is, are you including 10 and 20? I don't see anything about inclusive in here. I don't see anything about that. $3, $4 question said inclusive. So because this doesn't say anything about inclusive, I don't want to include 10 and 20. So if I don't want to include 10 and 20, I'm going to use 10.5 and 19.5. So that's a big issue. That's something that you've got to, make sure that you're very clear about when you're reading the question. What do I see the word inclusive? Is there any indication of inclusive? Remember when we did the girls reading the prayer, it said between 8 and 15 girls. So that's an implication that you're including 8 and 15. Okay, so 10.5 minus 16.67 divided by 3.73. I'm going to look it up. 19.5 minus 16.67 divided by 3.73. I'm going to look it up. And the classic between takes your two values, takes your two z-scores, and gets me an answer of roughly 73%. So therefore, the probability of rolling a 6 between 10 and 20 times is approximately, notice how I'm using that word quite a bit, right? Careful with your form. Approximately 72.69%. So you've seen a between with inclusive. You've seen a between without inclusive. I love this between because it's more challenging. You've seen a at least question. So we're kind of getting there, right? Like we're seeing some definitely more challenging questions. Okay, we're almost there. One more example. On a multiple choice test, there are 4 possible answers to choose from. So they're envisioning this type of thing. Each question has 4 possible answers. Okay. There are 50 questions on the test, and a student merely guesses at the answers. What is the probability that the student will pass? Okay, so I don't see the word between here, so I'm not guaranteed a normal. There's 50 questions on the test. A pass would be anything greater than or equal to 25, right? So if they will pass, it could be anything greater than or equal to 25. So that would mean if I was doing it regular Bernoulli, my God, that would mean 25 iterations of the formula. That would be crazy. If I was doing it reverse psych, 1 minus opposite to the question, that would mean 1 minus anything from the probability of 0 to the probability of 24. So that's going to be ridiculous too. There's nothing in here about waiting time. So I think I'm going to try normal approximation. Now, before we jump into the testing, let's just jump back here because I often get some questions when we're sitting in the class together, right? And people will say to me, what's the probability that the student, it's just saying, Miss Martel, what's the probability that the kid passes? No, it's not. It doesn't say what is the probability that the student just passes. Will pass. Will pass implies a pass and anything more. Okay, so be careful of that too. We often get into a little discussion where the kids in the class will say to me, Miss Martel, I just thought that meant that the kid gets 25. No, will just pass would be the wording of just getting 25. So 50 questions on the test. Now, probability of success. That means the probability of success on a question. So that's going to be 1 over 4. Because for each question, the probability that they're successful is 1 out of 4 possible answers. Probability of failure is also going to be on each question. And that's going to be 3 out of 4. So 50 over 1 times 1 over 4 is oops, sorry, I was going to write 11 and a half, 12 and a half. 50 over 1 times 3 over 4 is 37 and a half. So we've passed the test. Both values are greater than 5. My X bar already done for me, so that saved me some nice work. My sigma, I'm going to do right now 50 times a quarter times 3/4, all square rooted, again being careful, 3.06. Okay, now step 3. Well, this isn't a between. I'm looking for greater than or equal to 25. Greater than or equal to 25, knowing that I can't use 25, right? I'm well aware of that. So 12.5 is my average. 3.06 is my standard deviation. Am I going to use 24.5 or am I going to use 25.5? And the answer to that question depends on whether you're including 25. And we are including 25 because 25 constitutes a pass. So my hot pink value, sorry, better be consistent with that, is 24.5. 24.5 minus 12.5 divided by 3.06. Oh my God, is this a little Lisa question? Did I screw up in some way? 50 questions. So your average is representing the number of questions, the average number of questions being correct. So I think I don't have 2 units of measure. I've done my calculations. But I can't have a z-score greater than 3. So what's this telling me? What this is telling you is that the student is basically guaranteed to fail. Now, how am I making that statement? Okay, so if my average is 12.5 and 25 is somewhere over to the right, and this represents your z-score, which is over 3, significantly over 3, and your z value always represents your percentage below. Okay, so the z value that's semi-associated with this is roughly 100%. It's telling you that there's roughly 100% chance that the kid's gonna have a mark below 25. A mark below 25 is that the student is guaranteed to fail. So why I like this question is because it makes you think and truly understand what z-score is, what z-value is, that this would, is an outlier type of situation. So what's great about this question is the analysis part. Okay, it's different, it's harder, but it's a great question, and that's why I wanted to show it to you. Okay, so don't forget, we're on the countdown. We're at 3. Tomorrow we'll be at 2. Colored sheet will be at 1. And then the course is done. And you've done a fantastic job. Take care.